welcome you all in 24th lecture of Electronics Measurement and Instrumentation. In this lecture, I will discuss the different type of temperature transducers. Transducers are the device that converts one form of energy into another form. In this lecture, I will discuss the temperature sensor, what is the basic principle of temperature sensor, what are the different type of temperature sensors, applications of temperature sensors, advantage of temperature sensors, and what are the different criteria by which we can select the temperature transducers. And I will also discuss about the thermistor, that is the PTC and NTC, positive temperature coefficient thermistor and negative temperature coefficient thermistor. So, temperature sensor. Temperature sensor is a piece of electronic equipment that detect the temperature of its surrounding and transfer it into electronic output data to control, record and signal temperature variation. So, temperature sensor basically it is a transducer which converts temperature into electrical signal. We are using temperature sensor in our daily life, like we are using it for the domestic water heater, in refrigerator we are using temperature sensor, microwave, geyser. So, in daily life we are using temperature sensors at many places. Apart from that, we can use the temperature sensor to sense the concrete structures, the temperature of the concrete structure, bridges and soil, the moisture. If it is there, then suppose if we are going to construct a bridge in the northern portion of the India. So, there is temperature variation from 0 degree to 50 degree. So, this wide change in temperature, the structure may be impacted on that change in temperature. So, we have to take consideration of these temperature change. So, when we are going to design a bridge or we are going to design a concrete structure by which we can use a tank for the purpose of tank, then we have to take care of the temperature change. So, the temperature sensing, the temperature variation and the temperature measurement is required also there. Then this picture I have taken from the internet. There are different type of transducers are there, like PTC transducer. So, this is the thermistor type of transducer, that is positive temperature coefficient transducer. This is another type of transducer, that is thermocoupler transducer. So, these transducers are required to be placed inside the tank where we want to measure the temperature, but these are the pyro type transducers, these and these. So, they are the infrared transducers, and these transducers are not required to place the surrounding area where we want to measure the temperature. Similarly, there are the other type of transducer. This is a thermometer that we are using in our daily life. So, this thermometer basically senses the temperature of human body. So, it also converts the change in temperature into change in volume. In this type of thermometer, we know that the mercury is placed inside a tube, inside a glass chamber, and we know that when temperature increases, the volume of the mercury also increases. So, since it is placed in a transparent tube, then the change in volume is detected by the change in temperature. So, this type of thermometer, it is also a transducer, it converts the change in temperature into change in volume. Similarly, thermocouplers are there which converts the temperature change in temperature into change in voltage. There is another sensors, LM35 sensor. These are the IC sensor which we can place on a PCB, and it is also available in the form of surface mounted devices. And these are the useful for the where we want to place the PCB with this component. Then classification of temperature sensor. Temperature sensor can be classified into two types. One is contact type and other is non-contact type, contactless sensors. contact lens sensors are known as pyrometers, and contact sensors means the sensor that we have to place where we want to measure the temperature. But these two type of IR sensor and optical pyrometer, we can measure, suppose there is a boiler and we want to measure the temperature of the liquid which is under that boiler, then we can place it at the remote place at some distance from that boiler and we can measure the temperature. So, thermocouple, thermistor and RTD, resistance temperature detector. So, these three types of temperature sensors are of contact type, and IR sensor and optical pyrometer is of non-contact type sensors. Then thermocouple. Figure shows the thermocouple transducer. This thermocouple transducer is made up of two dissimilar wires. If we place two dissimilar metal like this way, we connect it and we can place it here. Okay. And we connect it. So, at this point if we use if we weld it, then and this is placed inside any chamber, then these two portion, in between these two portion, it will show the change in temperature. So, thermocouples are made up of two dissimilar metals, such as one wire is of constantan and other is of copper, and we combine it by the welding. So, at one section it for the comparison, because for the reference purpose, we can place one end of this at a cold junction, another end which is placed inside the chamber, that is a hot side, and then we can note the change in voltage, and that change in voltage is the proportional to the change in resistance, and it has a very wide temperature range, accuracy, sensitivity, reliability, and it is very simple. Then second type of contact type of transducer, temperature transducer, is the thermistor. So, thermistor means it is basically a thermally sensitive resistor. So, thermistor means thermally sensitive resistor, and it the change, because the thermistor is made up of oxide, that is it is made up of semiconductor material, and we know that in semiconductor material, when temperature increases, the resistance of semiconductor material decreases and its conductivity increases. So, thermally sensitive resistors has modification of the physical appearance due to change in temperature. The thermistor are constructed from ceramic substance like oxide of a particular metal covered with the glass. It is covered with glass, so to protect the that particular device. So, thermistors are made up of semiconductor material, and it is of two type. One is positive temperature coefficient thermistor, and second is negative temperature coefficient thermistor. When it is made up of semiconductor, then it is negative temperature coefficient thermistor, and if it is made up of mixture of metal with semiconductor, then it is positive temperature coefficient of thermistor. Then RTD, resistance temperature detector circuit. It is made up of precise conducting metals like platinum, which is covered in a coil. The electrical resistance of RTD, as its name suggests, it changes with the change in temperature. So, these are the basic structure of thermistor, and this is the basic structure of the RTD. Then next is infrared. These are the contactless sensors. That means, we are not required, it is not required to place them inside the surrounding in which we want to measure the temperature. So, infrared sensors, it is shown in the figure. Infrared sensors are used for many purpose. It is also used for the measurement of the speed of the vehicle. It can be used for the detection purpose also. But in the infrared sensor, that is used for the temperature device, for the measurement of temperature, then it is made up, suppose if there is a material, metal or anything. So, if the temperature is raised, means from 0 degree to any other degree, then there is a variation, there is a vibration or the movement of the molecules. So, that variation or the movement of molecules are increased as the temperature is increased, and during the movement of molecule they generate infrared light, and that infrared light is sensed by the infrared sensors. So, that infrared sensors has a lens there, that lens concentrate the light emitted by that particular device, and as the temperature increases the emitted light is also increases, and that emitted light is sensed by the infrared sensor. So, this is the infrared sensor, and it converts the change in infrared light is not visible, and it is detected by the infrared sensor. So, that is also a IR sensor can measure the heat of an object as well as detect the motion of the object. The next is the optical pyrometer. Optical pyrometer is again it also senses, we know that when the molecule moves, when the temperature increases the molecule moves, and when molecule moves it generates IR frequency, IR signal. So, that, and we know that the working principle of this is also that when it produces the IR signals, then the brightness also increases, and that brightness of that particular device is captured by the filament within the device, which is placed in the optical pyrometer, and that way the optical pyrometer detect that the change in temperature. The next is semiconductor based temperature sensor. Semiconductor based temperature sensor use the basic principle of the diode, that when the temperature is increased the voltage across diode increases, and that the change in the voltage across the diode is proportional to the change in temperature of the device. So, that change in temperature can be detected and it can be amplified, and that can be detected. Now, application of temperature sensor. The temperature sensors are employed for verifying model supposition that will improve more economical and safer construction. So, we can use for the construction purpose we can use the temperature sensor. So, we can analyze what temperature affects on the construction of bridge or the construction of house or anything, construction of dam. So, we can analyze using temperature sensor and we can construct accordingly the structure. Then they can detect rock temperature. So, they can detect rock temperature in order to identify storage tank of liquid gases and ground freezing process. Then temperature sensors can also be used in land boreholes and reservoirs and to measure water temperature. So, if temperature of water reservoir, if the temperature of water increases, then the volume of the water will also increase. So, for this purpose we can use temperature sensor to sense it. Then they are employed to interpret temperature in dam to reduce stress in volume variation and control the temperature variation on other installed instrument like curing concrete, etc. Then what are the advantage of temperature sensor? So, temperature sensor we know it is of low cost, precise and extremely reliable in repeated experiment. The deformation does not take place generally in temperature sensor. Then they are available in embedded form and surface mounted devices. So, they are very much suitable for the PCB purpose, because they are available in embedded and STM form also, surface mounted form also. Their response is very fast, and because of low thermal masses. They generally have IP68 rate. It means ki they can withstand in water also, and they can withstand with dust also. So, the dust will not affect the performance of this temperature sensors, and they are placed inside the weatherproof body. Then they can be used for the remote detecting, and we can also use for the data logging purpose. Their temperature probes can have precise linearity and low hysteresis. Low hysteresis means suppose we want to measure the temperature, and when the measured temperature, the resistance, when the temperature rises, then it has one curve, and suppose the from when we want to measure the temperature when it is in reducing form from high to low, then it will follow the next path. So, it has this value is known as hysteresis. So, less hysteresis is there in temperature sensor. Temperature sensor follow the same path whether it is measured from 0 to high, low to high and high to low. So, they will follow the same path. So, hysteresis is also low. Then temperature sensors are also available in airtight boxes and fully sealed by electron beam welding. So, it is inside the vacuum chamber. So, it will not be affected by the other surroundings. Then steps for selecting a temperature sensor. What are the different precautions we should take when we should select a particular sensor, temperature sensor? So, first thing, based on the measurement application and requirement. So, first is the response time. It means suppose we want to measure temperature of any chamber whose temperature changes very frequently, then we need a temperature sensor which has a very high response time, very quick response time. Quick response time means ki it can give the change in voltage as per the change in temperature. So, it can detect a small change in temperature in very rapidly. If temperature is rapidly changing, then we need a temperature sensor which is responsible for that change. Whether it is costly sensors, but we have to use that. But suppose there is a small variation is there. Suppose we want to measure the temperature of a boiler and it is changing very slowly, then we can use a sensor which has a less response time. Then second is the length of deployment service, selection of the sensor type durable enough to reduce maintenance. So, maintenance means suppose we have placed the transducers, the temperature sensor at a place where the maintenance is not possible, then we have to select a type of sensor that do not need much maintenance. So, that we should take care of that. Then accuracy requirement, suppose if the change in temperature is very less, accuracy means that how much the measured value is close to the true value. So, accuracy is the sensor should have very high accuracy at overall measurement range. Suppose we want to measure a temperature which is varying from 0.01 degree and we want to measure it, then our sensor should have that capability to measure that, and it should have the same accuracy for the overall range. Then based on temperature range of the measurement, then we have to select a sensor that can operate beyond the full range of possible temperature. Suppose we have to measure a temperature from 100 degree to 700 degree, then our temperature sensor should have the capability to measure the same response, to give the same response, same input output ratio for all the temperature, means it has a linear output for all the temperature range. Then selection of sensors with the most linear response over the range to improve the voltage to temperature conversion accuracy, because the temperature is to be converted into voltage. So, it should have same accuracy for all the conversion. Then environment in which the sensors are deployed. So, we have to take care of the sensor, which sensor we are using, that if the sensor is exposed to the chemical environment. So, we have to cover it with that metal sheathing material that is to resist the chemical exposure of the sensor. Then need of isolation to prevent ground loop and noise. We have to prevent our sensor from the noise generation. If there is a noisy environment, then our sensor, or if there is a sensor which converts the temperature into voltage, but with some noise. So, we should not, and if the variation of the input, variation of the temperature to voltage is very low and the noise is introduced in that, then it is very difficult to segregate that signal from the noise signal. So, proper isolation is needed from the noise. The next, the make sure sensors are related to withstand vibration and abrasion if they are exposed. So, it should be withstand with the vibration if it is used at a place where there is a vibration, because in mechanical industry the sensor is placed at one place and the vibration is at other place. So, that it should not be affected by the, its reading should not be affected by the vibration. Then mounting of sensor is to maximize the thermal connection. So, mounting should also be taken care of. Then thermistor. What is thermistor? So, thermistor is basically a type of resistor which converts electrical resistance into change in temperature. So, thermistors are made up of semiconductor material, and semiconductor material we know that when temperature changes, the conductivity also changes. So, thermistor are thermally sensitive resistor, it is short form thermistor, and they are used for the temperature range from -60° centigrade to 300° centigrade. They have resistance in the range of 0.5 ohm to 0.75 mega ohm, means it is having a range, it is having a variation from 0.5 ohm to 750 kilo ohm. And for every 1 degree rise in temperature, there is a decrease or increase of 5 degree in their temperature. So, sensitivity is also very high and better than the thermocouple or RTD. There are 3 type of temperature sensor which are of contact type. One is thermistor, thermocouple and RTD. So, the sensitivity of thermistor is very much higher than the other devices, other sensors. And then the type of thermistor. Thermistor are of 2 type, one is negative temperature coefficient and other is positive temperature coefficient. So, in negative temperature coefficient it has when the temperature changes, the change in resistance is negative, because we know that in semiconductor when temperature increases, then the number of electrons produced are more, and so the conductivity increases and temperature decreases. So, the change in temperature can be detected by change in conduction, or we can say the change in resistance. Similarly, positive temperature coefficient thermistor, they have property that when temperature changes, its resistance also increases. So, in conductor we know that if temperature increases, then collision of electron increases, and because of that the temperature also the conductivity also increases, the resistance also increases. So, conductivity reduces. So, these 2 type of thermistors. So, I will discuss it in the next lecture, what type of thermistors we are going to use, what are the different selection criteria of thermistors, or what is the different selection criteria of different type of transducers, thermistors, temperature transducers. So, in this lecture I have covered about the different type of temperature transducer, what are the different application of the transducers, temperature transducers, and in previous lecture I have covered the transducers, the basics of the transducers. So, in these 2 lectures, first lecture I have covered, I had covered about the transducers, the type of transducer, what is the function of transducer, and how do we select a particular transducer. And in this lecture I have covered about the different type of temperature transducers, because temperature transducers are very much useful in our houses also. They are also useful for the controlling purpose of this, that means the thermistor, this is also useful in used in our this AC circuit. So, it when it is heat up, then it will cut off the AC. Similarly, in digital thermometer, that nowadays we are using digital thermometer for the measurement of body temperature, then thermistors are also used in that place also. In a digital thermometer there is no copper wire, but it is a thermistor which we have used, and thermistor is very sensitive. that means 1 degree rise in temperature, then there is a increase or decrease of 5% of the resistance. So, sensitivity is very high and we are using the thermistor in the digital thermometer. So, this is all about this temperature transducers. Thank you all.